Hello. Today I'm going to demonstrate a little bit about using a binomial distribution probability. Now, you probably might have read 6.1 where it's talked about discrete random variables, which in any case we've kind of already talked about that, which is more or less just like something that's countable. But to be more specific, if we're going to compute a binomial probability, essentially you're dealing with discrete random variables. So in any case, when it comes to a binomial distribution, you're always given like some type of specific success, such as like the probability of having a girl is maybe a half, versus the probability of not having a girl, or even in this case a boy, is also one half. So that's kind of one way to look at it, and we can demonstrate, like if it's a die, well, a die is 1 out of 6, but the probability that your number does not show up would actually be 1 minus 1/6, which in this case would be your failure probability. But in any case, success and failure is kind of like it's like subjective in any case. So what we can do is, let's say for example that we want to do a binomial probability problem of where we start primarily from choosing the second vars button, and what we're going to do is we're going to scroll down to where it says binomial CDF or binomial PDF. Okay, so you'll see that there's a binomial PDF and a binomial CDF, which in any case, all that this means is that the binomial PDF means that you're calculating an exact probability. So for example, if I roll a die 4 different times and I want to know how many times, or what is the probability that a 3 shows up exactly 2 times out of the 4 rolls. Well, in that case, I'm going to use a binomial PDF, versus if I'm going to do a experiment of flipping a coin, let's say 10 times, and I want to know what is the probability that tails comes up no more than 4 times. Well, in that case, I'm going to use binomial CDF. We say binomial CDF because this is actually more or less a cumulative type of probability. So that means that you'd be going from 0, 1, 2, 3, and then you probably would stop at 3, because if the question said no more than 4 times, then in that case you would stop at 3. Versus like if it said at most 4, then yeah, you would include 4. So in any case, some of these problems, it's dealing with knowing, what's kind of like the key words essentially. So let's say that we want to calculate the probability of an exact binomial distribution. So let's just go ahead and select binomial PDF. Now, the trials is the number of times that the experiment is conducted. The P is basically the probability of success. But remember that the success failure, you can kind of like interchange it. Like for example, if for instance you were looking for the probability and it was respective to the failure, then in that case you would make the P the failure value, and the other way around. But let's say that we're gonna flip a die, let's say 5 times. Okay. Now the probability of success that, for instance, like if I roll a die and one of my values between 1 and 6 shows up, well, in any case, it's pretty intuitive that it's actually 1 out of 6. Okay. Now, we also have that the x value is actually the number of successes. So if I roll my die 5 different times and my value shows up 5 different times, then in that case, that means that the x value would be 5. Now, let's say that we want to know what is the probability that my number shows up twice. Now, in this case, we just hit enter. Now, for those that have an older calculator, most likely it's going to give you like binomial PDF and then some parentheses. So in that case, you just put it in order as NPX. Again, that would be N, comma, P, comma, X, close parentheses. Okay, so we're just going to put enter and see how exactly it looks in order. Binomial PDF 5, comma, 1, 6, comma, 2, and then we just hit enter. Okay, so apparently the probability of rolling the number of your choice 2 times out of the 5 is 0.16, or for that matter 16%, if we just multiply by 100, and that converts it to percentage. So we have that that's 16%. Now, in that case, I could actually calculate the complement of this, which means that I can find what is the probability that my number does not appear 2 times. So in that case, I'm just doing 1 minus the answer, and then just hitting enter. So I might have did that wrong because that was respective to the percentage. So maybe like 1 minus, and then let's just grab this over here, hit enter. Okay, so there's an 84% chance that my number will not show up 2 times out of the 5. Now, in that case, if you were a betting person, then you would say that it'd be probably a little more wiser to bet against versus for. Okay, now let's say, for example, that we wanted to use the binomial CDF. Now, the binomial CDF is more or less a cumulative type of probability. So, like, for example, if we wanted to know what is the probability that a family of 6 has at most 2 boys. So because I said at most, then in that case I would have to use the binomial CDF function due to the fact that I'm including from 0 up to that value. So in this case, we'll use binomial CDF. It's going to be a family of 6. Now, the respective probability of having a boy is going to be 1/2. So in that case, we'll just use 1/2. Now, normally the probability of success is given, but if not, then it can kind of be figured out, kind of like if you think about it, like a deck of cards, or a die, or a coin, or true-false questions, and so on. Now, I don't really remember the value that I was going to try. I think I said at most 2 boys or 3 boys. Let's just go with 2 boys. Okay, so we're saying that we're going to calculate the probability that the family has no more than 2 boys, or at most 2 boys, I'm sorry. So we're going to find the probability that the family has up to 2 boys. Now keep in mind that that's actually calculating if they have no boys, 1 boy, or 2 boys. So okay, we're just going to hit enter. Now, of course, if you have a older calculator, it's not going to show you that menu that came up, but you are going to select binomial CDF, and then it's going to give you like the parentheses of which you do the N, the P, the X. Again, that's N, comma, P, comma, X. Now, remember that the probability of success is relative to whatever we're talking about. So in this case, we're talking about boys. So in that case, it's 1/2. Versus if we were saying, like, what is the probability of not having a boy, then in that case, you'd still put the 1/2 because it's the complement of 1/2. Okay, so in any case, we'll just hit enter. And there is about a 34% chance that a family of 6 will have at most 2 boys. So in that case, that means that the probability of 0 plus the probability of 1 plus the probability of 2 is 34.38%. We'll just say that. Now, as you go ahead and you try to figure out some more computations such as expected values, um, keep in mind that it's as simple as actually just inputting a formula. So, for instance, if I wanted to know the expected value of the number of boys in a family of six would be, I actually would just do 6 and then multiply it by a half and then just hit enter, of which I get 3. Which, I mean, that kind of makes sense because if it's a family of six, then you would expect that half of the children would be boys. But that's not always the case. Okay, so that's one thing to consider, is that it's not the case that the family should have 3 boys, because there is the possibility that the family of six, or the children six, would be all girls. Okay. Now, of course, in binomial distributions, you can also calculate the standard deviation, of which the standard deviation is as simple as doing the square root of the value of your trials, which in this case, let's say that we're doing the boy girl experiment. So we do 6, we multiply by the p, which is a half, then we multiply by the complement, which in this case is also a half. Now, for those that would rather do the actual computation, like 1 minus a half to get the complement, you can do that, and it gives you the same thing. Okay, so if I hit enter, I get that the standard deviation is 1.22, of which that's just telling me that the standard deviation is 1.22, and on the contrary, we have that if we square that, that gives us the variance of 1.5. Okay, so the variance is actually just the squared of the original standard deviation number, of which in this case, note that that's actually just the n, the p, and the complement of our success probability, which some people call a q. Okay. Now, the best thing to do with using a binomial distribution is that you actually would practice in terms of like figuring out what the question is asking, and then also like practicing the differences between binomial CDF and binomial PDF. Remember that the binomial PDF is for calculating an exact probability, versus that the binomial CDF is for calculating a cumulative probability. Okay, that's going to be it. Let me know if you have any questions, and until next time.